Welcome everyone. I am Filippo Visintainer from Fiat Research Center, part of Stellantis Group, and I will be moderating the breakout session number 8 on standardization and roadworthiness in cooperative connected and automated mobility. What are the achievements and next steps? Moving from driving assistance to automated driving, new challenges come into play, demanding new standards. In this session, we will address the current and planned contributions to standards, the latest regulation for CCAM, and how they would benefit from standardization. In particular, we want to highlight the major challenges or open questions for a widespread deployment in automated vehicles. In summary, we will check the current needs, limitations, challenges, and gaps in the standardization. How are these impacting on the deployment of connected and automated driving? How can we overcome these needs, limitations, and what are the R&I challenges? So the goals will be to get information on ongoing standard activities, as you will see from the presentations, to identify the standard gaps, prioritize them in the interactive session, and highlight the main challenges and possible roadblocks, to collect recommendations of new standards in connected and automated driving, and finally, to create a community and consensus on the standard needs. And on this, we rely also on the interactive polls. So there will be a first part of 5 speeches, then an interactive session, and finally a Q&A session. Now I give the floor to the next 2 speakers from Canada, Nikki and Geoff Knapp, who will give a joint presentation about connected and automated vehicle standard initiative of CSA Group. But before I introduce them, here's a first poll to the audience. How familiar are you with CSA Group research on the connected and automated vehicle technologies in Canada? So please, the poll, while I'm introducing the first speaker. Actually, this is a joint presentation by Nikki and Geoff Knapp. Nikki is the Manager of Strategic Initiatives of CSA Group's Fuels and Transportation sector. Her key responsibilities include representing CSA Group in developing and maintaining strategic alliances with stakeholder groups, including industry, government, consumers, and academia. Nikki joined CSA Group in 1990, where she has held several increasingly more senior and diverse positions in sales management. For the past 5 years, she has been focused on strategic initiatives in the fuels and transportation sector. Geoff Knapp, the second speaker within the same presentation, has 22 years and more of experience in transportation engineering consulting with a focus on ITS, including connected and automated vehicles and emerging technologies. He's a recognized expert of the ITS architecture of Canada, having been involved with all aspects relating to its development. Geoff is active in the CAV industry in Canada as a voting member of both the CSA-CAV Advisory Committee and the Transportation Association of Canada CAV Task Force, and as a co-chair of ITS AV Shuttle Technical Committee. Geoff is currently leading the CAV and Smart Mobility Services on retainer for the Ministry of Transportation of Ontario. I now give the floor to the first speaker, Ms. Nikki. Please.
Thank you. Good morning and good afternoon and good evening, everyone. I'm going to present on CSA Group, our Connected and Automated Vehicles Standards Initiatives. Next slide, please. I will walk through a CSA Group overview of our organization in the standards development side of the business. We will talk to our CSA CAV initiatives, our work through our Transport Canada ACATS project. I will then hand it over to Geoff to talk to our CSA Group research report, Insights for Codes and Standards in Canada. And then Geoff will hand it back over to me and we'll talk about what we're doing moving forward in regards to our Codes and Standards roadmap, digital infrastructure guideline, our connected and automated vehicle code, and also the work that we're doing with our Connected and Automated Advisory Council. Next slide, please. CSA Group is holding the future to a higher standard. For over 100 years, CSA Group has helped make the world safer, more sustainable through testing, inspection, certification, and development of standards. At CSA, we take a comprehensive approach to standards development. We engage in leading-edge research to help inform standards content. We also provide training and education products to ensure that the standards are applied correctly to help ensure the comprehension and application of the standards we publish. We advocate the importance and the value of standards to drive public awareness and engage the new generation of standards developers and users. Next slide, please. The CSA Standards Research Program was launched in 2016, and to date we've published more than 60 reports. These are all available for a free download from the CSA Group website. We utilize this program to fund the CAV research, which Geoff will talk to in a couple of slides. Next slide, please. CSA Group received funding from Transport Canada through the ACATS project, which is the Advanced Connectivity and Automation in the Transportation System. Through this project, we were to develop a guideline, standardization roadmap through stakeholder engagement to safely deploy connected and automated vehicles into Canada. The key objectives from this project was to engage stakeholders. This was done by kicking off a 2-day workshop in November of 2018. And we continued that engagement throughout the 3-year cycle of the project. One of the recommendations from that was to form a Connected and Automated Vehicle Advisory Council. So that was formed, and it serves in an advisory capacity to CSA Group. We also engaged our CAVAC members to discuss international standards development and participation. So we receive regular updates from those council members, and we also have SAE represented on our advisory council, and then the members sit on the ISO and IEEE committees. Another key objective was to create a codes and standards roadmap. And it was clear that we didn't have enough information to complete the roadmap, and that's where we utilized the CSA Group research program to assist with the information to support that. And develop a guideline. So CSA Group's Advisory Council Digital Infrastructure Working Group was critical in gathering the content for that guideline. Now I'm going to hand the presentation over to Geoff Knapp of WSP Canada to walk us through the CSA Group CAV research project. Next slide, please.
Thanks. I'm just going to do a quick review of the research study seen here that we completed to support the ACATS project that Nikki introduced. I should mention that our research was 3-tiered. It included primary research through direct interviews with key industry stakeholders, including private sector companies and associations, public sector agencies, and active academics. We also undertook secondary research through desktop scans of available reports and publications globally, so not just North America, but internationally. And then finally, our team included industry experts from WSP, as well as a sub-consultant, Consistec, in the US. Next slide, please. So based on the findings from this research, gaps or critical need areas were grouped into 8 themes shown here. I think it is important to note that not all were necessarily gaps so much as just known issues or needs or concerns of stakeholders. An example of this is the first theme, where because Canada shares a border as well as a common automotive industry with the US as well as Mexico. So harmonization and interoperability is a critical need in North America. You want to be able to drive your automated vehicle anywhere. And then uncertainty and with enabling communication technologies and reserved spectrum allocation was also an important issue that was raised a year and a half ago through stakeholders. As you may know, that the FCC has since proposed drastically decreasing available spectrum for ITS, and while previously supporting DSRC, they have recommended a move to CV2X communication technologies. There seemed to be some clarity in the fall, but since that, the change in administration in the US, there has been no move past beyond proposing those changes. So the uncertainty remains. The last theme, just going quickly, technology maturity was used as a catch-all of sorts to capture stakeholder input that related to specific examples that will likely not be addressed through standards, but say through improved technologies or more operational experience, which will help machine learning and AI to better manage automated driving. Next slide. Building off the themes, we provided the CSA with a number of recommendations for their roadmap and program. The first relates to the need for harmonization and interoperability, which we talked about, and that means working actively with the US counterparts, particularly with respect to communication spectrum and technologies, physical infrastructure, and security and credential management system implementations. I'll pass it off to Nikki now. Next slide.
Thank you. Next. So moving forward, what are some of the initiatives that CSA Group's got on the go? So our codes and standards roadmap, after the research was published, we formed 4 working groups under our advisory council for digital infrastructure, physical infrastructure, usage human machine interface accessibility and vehicle aspects, and cybersecurity data management and privacy. These working groups identified and prioritized gaps in codes and standards, which was used to advance the development of the codes and standards roadmap. The findings from each of these groups were presented at an industry progress workshop that we held virtually in January of 2021 to validate the roadmap. It's currently being reviewed by our advisory council, and the plan is to publish this in May of this year. Digital infrastructure guideline. So the Digital Infrastructure Working Group under our Advisory Council provided the initial content for the guideline. CSA has put together those details, and the working group is currently reviewing the draft content. The guideline is to be published in May of 2021. The Connected and Automated Vehicle Code. So one of the recommendations out of the research report was the need for a code. So based on our initiatives and consultation with stakeholders, CSA Group is developing a binational model CAV code for the Canada and US. So we have filed the initial paperwork for through Standards Council of Canada and through ANSI to have this, and we've had support from SAE International in the US and also from Transport Canada. So the framework of the CAD code that will be developed will be used through the phase 2 of our CSA Group research projects. So we actually right now have that being reviewed by our advisory council, and the report for the framework is planned to be published in June of 2021, and that will be available through the CSA Group website. So now we're in the process of developing a seed document for the CAV code. So this seed document will be used by a technical committee to start working on the code. We're in the process right now of assembling the technical committee. The CAV code will specify infrastructure requirements for CAVs operating or intending to operate in both on and off-road environments in order to address public safety, security, and privacy challenges. The code will include physical and digital infrastructure with considerations given to cybersecurity, interoperability, data management, data privacy, and data integrity. We are going to continue our stakeholder engagement through our CAV Connected and Automated Vehicle Advisory Council. So this council was formed back in 2019. It engages 53 members on codes and standards development and coordination. CSA plans to connect with this group every quarter. Next slide, please. This is linked to the CSA Group research report. Should anybody have not had a chance to view it, it's available for free download through the CSA Group website. And next slide. And that's it for CSA Group. I will hand it back over to Filippo.
Okay, thanks very much, Nikki and Geoff Knapp, for your presentation. I think it's very useful also because I see the audience was generally not familiar with the CSA groups. I kindly ask Michele Giorelli if there have been questions from the public or if there are questions now from the audience.
No,
No questions?
there is just one right in this moment. Okay, we can see that. I can read that. Okay.
Yes, please.
Yeah. What kind of regulatory value? Yeah, this one that you can see now on the screen. What kind of regulatory value will the CAV code framework for Canada and US have? Guidance for national law or something more?
Okay,
So,
please.
yes, thanks for that. The initial plan, that was one of the reasons why we engaged both Transport Canada and SAE International in regards to that. The regulator obviously is Transport Canada, and the guidance is if there is a code that is created, the authorities having jurisdiction within Canada can reference that code, and that would allow for, like Geoff spoke about, the harmonization and interoperability throughout each province, because we actually don't necessarily have borders between our provinces, so vehicles flow freely from one province to the other. So the guidance is then the policymakers would have something to actually reference as a tool for anybody wanting to deploy a connected and automated vehicle. I hope that answers the question.
Okay, thank you. Thank you very much, Ms. Kidd and Mr. Geoff Knapp. Let's move on quickly to the next speaker. Next speaker is Professor Thomas Zielke, Professor of Computer Science at the Düsseldorf University of Applied Sciences in Germany. He graduated in Computer Engineering at the Technical University of Darmstadt. He holds a Master Science degree in Knowledge-Based Systems from Heriot-Watt University, Edinburgh, Scotland. He received a PhD in Neurocomputing from the Ruhr University Bochum. He was president and CEO of Civis Computer Vision and Automation and was awarded the European IT Prize in 1996 for pioneering face recognition applications. He served as CTO in facial recognition for Crossmatch Technologies in Florida, USA, and his current research interests include pattern recognition, computer vision, machine learning, and artificial intelligence, which is going to be its main subject today.
Yes, hello. So I guess the first slide is already projected. No, not yet. Okay. Here we are. Yes. So I'm from the Hochschule Düsseldorf, which is the University of Applied Science in Düsseldorf. And please, next slide. My talk is on next. Okay, my talk is on artificial intelligence standardization, as I am a member of the German committee for working on this standard, and I'm also a member on in working groups of ISO that work on these standards. So the first question, of course, is why does artificial intelligence matter to, for example, automated driving? There is no generally accepted definition for artificial intelligence. It's just not there. But if you look into the patent world, for example, then you see that people using the terms artificial intelligence, for example, in many patents by Mobileye, this Intel company, most of you know, and Mobileye is using artificial intelligence as term in patents. So it matters for your field here for the automated driving. So next slide, please. Okay. This is a structure of the so-called SC42, the subcommittee 42 of ISO, which is devoted to the development of standards in artificial intelligence. It currently has worldwide 31 members, participating members. The most important thing is what kind of working groups are there, what kind of topics are worked on in official working groups and projects. And so there is mainly a group on foundational standards. Then we have one on use cases and application, on data, which used to be called big data, but it's just now concentrated on the whole field of data and all connected things. And then we have a group on computational approaches and computational characteristics of AI systems. One of the most important topics in the context of automated driving, of course, is the trustworthiness issue, which applies to all artificial intelligence systems. Please, next slide. Next, okay. As you know, we have two different kinds of artificial intelligence. Symbolic artificial intelligence and the sub-symbolic artificial intelligence. And to make it short for today, most of the impressive advances in artificial intelligence over the last decade was in this area called sub-symbolic artificial intelligence. And there many approaches are based on deep neural networks nowadays, and that it brings advances, but it causes a problem. Next slide, please. Neural networks are the main tool for machine learning currently. So you construct systems, for example, for automated driving, by learning from data. So it's a data-driven approach to artificial intelligence. And there are quite a big number of different methods for learning from data. And most practical systems are kind of combinations of several approaches. Next slide, please. Now, for automated software, you have an ISO standard. It's 26262 for the software validation and procedures for making sure that the software is flawless, works correctly, and all these kind of things. The problem is that this standard does not apply for machine learning components. So it is not applicable for machine learning components, and therefore a lot of research still has to be done to find methods or even standards on how to prove that system components that are constructed by machine learning are safe and robust, have a robustness, and can be, fulfill certain standards of trustworthiness. Next slide, please. Now, this applies in general, not only for the automotive sectors, in all the industry sectors that have safety critical components. Normally, rigorous software verification has to be done, but these methods exist for non-AI system, but not for AI systems. That is the problem. So there are some mathematical methods for verification of neural networks, for example, but as of today, this is still a research area. So you can do this on a mathematical way with very small networks, but not with very large networks as you need in an automated car, for example. So a major goal of artificial standardization is to identify and define methods and workflows that can establish a defined degree of trust in the robustness of the AI components that are in our future products. Yeah, that's the end of my talk. Thank you very much.
So thank you very much, Professor Zielke. Any questions? Michele, any questions in the meantime?
There is just one comment. I want to show that comment. It's more related to ISO 26262 and the consideration of safety related to in-vehicle or connectivity. It's just a comment from Antonio Consueli. I want to just show you. I don't know if there is any, any answer to that.
Thank you very much for that comment.
Yeah, we can come back to that. My background is actually connectivity and V2X. We can discuss it later. Okay. Thank you very much, Professor Zielke. I think the next questions can be addressed later on, also because we are running a bit late, but it's good. I've seen good presentation. Now, let's give the floor to Ms. Oyana Otaigui, who will talk about the standardization on interfaces and formats for CCAM validation. So Dr. Oyana Otaigui is in charge of the ITS and the engineering department of Ecomtech. She received her master engineering degree in 1999 in electronic engineering and a doctoral degree in 2005 from the University of Navarra. She has a substantial experience in satellite navigation and transport fields, especially in signal processing techniques and algorithms. Before joining, she works as a researcher in CIT, Spain, and Fraunhofer IIS, Germany. Since 2010, she's the director of the ITS and engineering area at Vicom, where she is involved on computer vision and machine learning techniques for automotive industries. She has been coordinator of Framework Program 7 and H2020 projects and technical coordinator of ESA project. Has more than 40 publications on satellite-based localization, LBS, computer vision, and ADAS. She's an external professor at the University of Basque Country and member of the Basque Academy of Science, Arts, and Letters. So please, Dr. Oyana, the floor is yours.
So thank you very much for this kind introduction. So as I have already been presented, I am Oyana Otaegui, and I work for Ecomtech, which is an applied research institution located in San Sebastian. So I don't know, yes. So I will try to summarize in these few minutes that I have the challenges in standardization regarding interfaces and formats, especially for the simulation and scenario-based testing. So next slide, please. So if we analyze the global market for autonomous vehicles has reached a value of more than 80 billion in 2019 and is increasing in 30% since 2015. So car manufacturers are investing a lot of money in the development of autonomous driving function and in the establishment of new cooperation in areas of sensor technology, data acquisition, and evaluation. The testing and evaluation of this complex and increasingly in complexity function is a challenge that comprises different edges in coming from market demand, OEM specific, for market differentiation, testing for meeting legislations like type approval and some complex certification. In all this testing and validation, the requirements on kilometers that need to be driven are different. And what we see from this slide is that each time that we are trying to enter a more complex driving function, these requirements are increasing a lot. The amount of driving kilometers that are required for validating some kind of L3 and L4 driving function is immense. And these driving requirements make it impossible to address this testing only by analyzing driving kilometers. And thus, the simulation and real validation need to be addressed in almost all the presented verticals in these slides. So next slide, please. So for testing and validation, we need to cover two main challenges. On the one hand, we are seeing here that we need to go through all validation stages and forms with a complete traceability in all the performance tests and the results. So we need to go from testing under simulation domains through X in the loop, so hardware in the loops, a vehicle in the loop, through proving ground, and even including the real world driving, while covering the second main challenge, which is what we are seeing in this slide on the right-hand side, which is the V-model validation approach to ensure the testing and the validation of the complete driving function and its individual modules. So this is quite a complex challenge, which we need somehow to address the traceability of all the tests that we are doing in all these verticals. Next slide, please. So if we integrate the standards in the process, this modified slightly this V model that I have been showing in the previous slide, including new milestones. The inclusion in the process of, for example, the ISO 26262 requires, for example, a hazard and risk analysis to be performed, and that the software and the hardware development runs in parallel in this V model, requiring an extra validation and testing to comply with this safety concept that we need somehow to address. This modification and milestone inclusion require a running in large number of tests, which implies for a complex system, including several cameras, radars, and sensors. So the extensive testing with millions of test kilometers to cover all types of situation and scenario that the system must handle. Therefore, it is not feasible to rely only on physical tests, not only at the development phase, but also in the testing and validation level. So the simulation can enable millions of tests without going through the tedious process of relying on real driving data management. However, this virtual testing should be representative of the real situation, and this is really a challenge. Next slide, please. Further extension to also include other standards like SOCTI make the situation even more demanding in relation to testing. Therefore, here is where we need new approaches to fulfill these testing requirements, and one of those options is the promising scenario-based testing. A specific scenario injection shall be considered to cope with the testing and the validation requirements imposed by the standards and the certification. The scenario selection, the variability, and the coverage will be main challenging topics in the near future if they are not already a challenge. Next slide, please. In this context, interoperability, data formats, and scenario definition played a paramount role. Collaboration is required to avoid unnecessary cost, for example, formal conversion, incompatible tooling, etc. The demand for exchanging formats and description for supporting the development of this system is constantly growing. Standardized approaches are indispensable, and in this sense, some standardization body has been working since 2018 in the OpenX standard family to pave the road towards the simulation-based validation requirements. This OpenX family covers the complete change from real driving data analysis with open label for generating metadata, road and infrastructure description with OpenDrive and OpenCRG, the maneuvers and dynamics for the traffic participant with Open Scenario, to link with simulation tools, the OSI standard, or even the ability of describing the operational design domain description with the OpenODD. In order to ensure the traceability, which is crucial, the dictionary concept and glossary all over the standards, the OpenX ontology is being defined. Next slide, please. So how to implement this methodology that can be addressed with the validation and certification requirement in the scenario test approaches? So Head Start project, which is a project funded under Horizon 2020, is working on proposing a harmonized methodology for CAD validation, including all testing pillars that I have been mentioned in the second slide, while maintaining traceability. The methodology addresses also the inclusion of key enabling technologies that will be key in the development of higher level of automated driving solutions. The methodology starts with the driving function under test, which has given given ODD and certification process to be tested. Based on these inputs, queries are run against a central database containing scenarios that has been included into the database via different sources, FOTs, real driving data analysis, or even knowledge base. Once functional scenario has been retrieved, parameter distribution is being conducted to cover all possible situations. In case that the CAD plays a role in driving function, an extra layer is added to this scenario to include the information of the individual scenarios. And these individual scenarios are pushed into the different testing methods and compare the results to check the coverage of the conducted test. Next slide, please. So matching the standards with the methodology, we can easily see where the previous described OpenX family standards will play a crucial role in enabling interoperability in the complete test and validation chain. A scenario ingestion, a scenario format, query to database, parameter distribution, CADs, inclusion of individual scenarios, injection in the simulation, and harmonizing test results. Next slide, please. So we can yes. So we can summarize that the standards and the methodology fitting in the following figure. So open label, open ODD will play an important role on the definition and query. Open label, the scenario description on the scenario injection, open label with the injection of the CADs, and open test for conducting the results analysis. Next slide, please. So to finalize, a mention of an application example on how to copy the certification to the whole process. The standards have no impact on the development of the regulation, but they have an impact on the application and implementation of this regulation. So from the regulation, an expert extracts the scenario related to the specific regulation. These scenarios are used to query the scenario database for function scenarios containing the described situation. Based on the regulation, interpretation of the parameters are being selected to generate combination and to cover the different situations that are described in the individual open scenario format. These scenarios are used to run the simulation, and using a harmonized open test standard, the results can be evaluated and can be done analysis whether the coverage is enough or not. In case that we lack of relevant scenario, we will need to generate them either by real driving or from expert knowledge. So with this, I finalize my talk. So next slide, please. Thank you very much for
Thank
attending.
you very much to you. It was very interesting, especially the Head Start methodology. Any questions from the audience?
There is just one comment there. You can read if you want. ISO 34500 serial. This one comment is from the Odyssey that they also include the scenario for autonomous driving system. I don't know if you want to comment about that or you have already knowledge about that.
Okay, so yes, thank you for the comment, and yes, we know that they also have the scenario-based injection. So thank you for the comment.
Okay, thank you very much. I think I now will hand over to the next speaker, Ms. Marta Tobar. Everything all right with the connection? You had some issues?
I hope so.
Okay, can everyone not involved in the presentation for this intervention turn off the camera just for preventive? Okay, so I will read out and then turn off my camera too. So Marta Tobar is the R&D responsible for the homologation department at IDIADA. She is an industrial engineer with a postgraduate in electric vehicles and other propulsion technologies who joined IDIADA in 2013. As R&D responsible for the homologation, she has participated in several European national projects on autonomous driving and fuel saving development, such as Ensemble, Aeroflex, Head Start, Arcade, and Show. She is also in direct contact with the experts attended to UN vehicle regulation forums such as WP29, GRVA, and its informal working groups and EC working groups. So she's an expert performing state-of-the-art and gap analysis, which is very important for this session, and regulatory framework recommendations from a technical service point of view. So you will hear about technical services in this presentation. Floor is yours, Marta.
Okay, thank you, Filippo, for your kind presentation. I hope you can hear me fine, and sorry for the technical problems. Also, thank you very much for inviting me to participate in this breakout session. Today we will see which is the progressive approach to regulate CAP. This is something that will be presented by Cristina, my next colleague. But we need to consider how these new assessment and testing methods will affect technical services. Next slide, please. Today, I will talk about the challenges that technical services have and will have to face when talking about these CAV regulations. The future trends for technical services will have to consider new tools. In 8 minutes, it is not possible to talk about all the pillars where a technical service has to be settled, so I will only present 4 of the challenges that we have detected. Next slide, please. So the first challenge is the qualified staff. Until now, the engineers part of a technical service only had to face empiric parameters in their daily work. With CAV future regulatory trends, a multidisciplinary approach is needed. It is not enough to know the regulation and their tests. The engineers now will need to know about the technologies and concepts such as functional safety, cybersecurity, or software updates. It is important to know both methodology, know-how, and also technology know-how. Next slide, please. So the second challenge is the state-of-the-art of the testing facilities. We are currently working in testing tracks that will have to evolve, will have to be flexible, modular, will have to simulate cities, buildings, even weather conditions. So referring to the pillars that are being right now discussed in the different UNEC working groups and automated in order to approach to automated driving, we will also need to consider real-world testing, which includes a favorable regulatory framework to test. Why I say that? Because we need to take into account that right now, each country has their own framework for testing in open roads. We will also need to talk about assessment and simulation with vehicle in the loop tests or even simulators. Next slide, please. The third challenge is the continuous training. Technology evolves day by day, and regulations need to do so. This means that technical service engineers will need to be ready for the changes. I like to say that the future from today is the past from tomorrow. Next slide, please. And the last challenge that I will talk about today is the preparation in the rulemaking process, in the rulemaking process. It is a fact that technology has evolved much faster than regulations. This is something that currently has changed. In the past, it took such a long time to regulate new technologies. Now, it is a matter of months. There is a frenetic rhythm in the regulatory forums, and the timing from the adoption of one regulation into its entry into force has significantly been reduced. This means that technical services have to keep looking to the regulatory forums, the discussions that are being held in there, and also be ready for their quick implementation. Next slide, please. An example of the evolution of the regulatory framework is the UN Regulation 157. This regulation is the first one that covers a SAE 3-level system. The ALKS controls the lateral and longitudinal movement of the vehicle for extended periods of time with further driver command. This regulation also considers the pillars that I have mentioned before, which are the audit and simulation, the track testing, and also the real-world testing. Next slide. So I will use my last minutes in order to talk about the European projects where IDIADA is participating related to CAP and regulations. One of them is Head Start. Oyana has already talked about Head Start, but well, I will talk about the different point of view. The main objective of Head Start is to define testing methodologies, including scenario-based standard validation procedures using a multi-pillar approach. In this direction, type approval needs for UN Regulation 157 will be used to demonstrate the results of the project in the context of regulations. Next slide, please. Finally, I will talk about Ensemble project, also very focused in platooning and how the regulatory framework should change in order to include the technologies developed within it. In addition, the project is working to collect the requirements for each country to test roads and also create a mutual recognition framework document. Which includes a knowledge base, also focused on standardization and regulatory framework. And finally, Show project, which is the project where demonstrators of connected, electrified, and automated urban transport will take place in cities of Europe. So with this, I would like to strongly invite you to visit the project web pages. And if you have any question, please contact me or any of the colleagues participating in these projects. And we will be happy to answer your questions. And with this, I arrive to the end of my presentation. Thank you very much.
Thank you so much, Marta. So everything went well with the connection. I'm happy. So any questions to Marta from the audience? Michele, can you please read out the question? I see them a bit little.
There are many questions, but probably the one that could apply to Marta, there are a lot of noise. The one that could apply to Marta is this one that I highlight here. It's possible to cover all the situations, such as a landing airplane, Animal Crossing, and in a highway? Well, it's a provocative question, but it's interesting.
I would say that if you're a millionaire and you have a lot of money to spend on this, of course, it is possible. The problem is that you don't have a limited amount of money, so you have to decide which are going to be the most representative scenarios to be tested. And this is a good discussion because I believe that we can continue with this and see which is the best way to validate this.
Okay. Thank you very much. We have additional questions for the Q&A session, which is very, very good. So let me now hand over to the next presenter, Ms. Cristina Galassi from the JRC, who will talk about the European regulatory approach to connected and automated vehicles approval. Ms. Galassi is a scientific project officer of the Sustainable Transport Unit at the European Commission JRC. She's leading the JRC activities on the development of a new EU type approval framework for automated vehicles with focus on safety requirements and validation. She studied aerospace engineering and received a PhD in nuclear and industrial safety from the University of Pisa. Before handing over to Dr. Galassi, we have a Slido poll. So she wants to ask the audience the following. Do you think that automated vehicles should be at least as safe as the human driver, or at least as safe as human driver with the state-of-the-art ADAS technology, so also considering the support from ADAS? Or third, at least as safe as reasonably achievable, so no need to set a minimum safety level. This is the poll. Let's check. Yes, it has been launched. So floor to Ms. Galassi. Thank you.
Thank you, Mr. Visintainer, for the kind introduction, and good afternoon to everyone. So as the moderator announced, I'm going to give you an overview on the Commission approach to regulate connected and automated vehicles. So first slide, please. So I hope you can hear me well. Otherwise, let me know. My presentation will be very short, but I would like to leave you three main messages. So my first key message will be about the innovative aspects of this new assessment method that we are proposing. Then I will give you a review on the current state of the regulatory efforts. And finally, I will spend a few words on the future plans. So as you well know, passenger cars type approval is mandatory in the EU since 1998, and the technical requirements heavily rely on UN regulations. The current approval framework, though, does not address connected and automated vehicles. So the question is, how can we regulate this new technology? The European Commission adopted a progressive approach, first of all, supporting large-scale testing. Then in 2019, the Commission issued guidelines, voluntary guidelines, of course, for the approval under EU exemption procedure according to Article 39 of the current regulation. And the text of these guidelines is publicly available. But the Commission was also looking forward because in 2018, the new EU legal framework was proposed not only to promote driver assistance systems, but also to pave the way for automated and connected vehicles. This new general safety regulation will be applicable from mid-2022. And at present, we are working at full speed, as the colleague mentioned in the previous presentation, to develop technical rules for the application of this new legislation by the end of this year. As GRC, we are also supporting the development of a new assessment method for the safety certification of automated vehicles, meaning that the focus is on level 3 and 4. Next slide, please. So, and here is my first key message about the new assessment method, which is being indeed developed. So the peculiarity of this approach is that indeed the safety assessment by the authority will not only cover one short part of the vehicle life cycle, but would rather address the whole vehicle life cycle, the whole ADS life cycle. Because the exchanges between the manufacturer and authority will start at the very early stage, during the development phase actually, with this first pillar, where you can read audit of the safety management system and also the ADS safety assessment that will be done through exchange of documentation package provided by the manufacturer. Then there will be a second phase of physical testing, a verification run by the authority. And as you can see, and as also the previous speaker mentioned, it will be fundamental to identify a common scenarios catalog as a common framework between the manufacturer and authorities to both assess the ADS performance and also for the safety validation by the authority. By the manufacturer. As I said, this approach will also cover the whole life cycle, including also the operation of the vehicle once it will be on road. And this will be done through in-service monitoring and reporting. And this exercise actually has been pushed by the GRC. As you can see, it was not there in the ALKS regulation as it was approved, because we believe that it is important not only to confirm the safety of the vehicles once they will be on road, but also to identify new scenarios not considered before the approval, and also to learn from the operational experience in real life. And this can be done also sharing the lessons learned in the form of safety recommendations with all relevant stakeholders. Next slide, please. So I mentioned that this new assessment method is of general validity. It means that it doesn't depend on the considered use case, but there will be, indeed, for its practical implementation, some adaptations to be done or to be developed concerning the different use case. On this regard, we exchange information with the stakeholders, and we developed most likely automated driving deployment roadmap for Europe. And we focused on the upcoming technologies, meaning highway chauffeur, level 3 for motorway application, and shuttles and robotaxi level 4 for urban application. Next slide, please. And this table, I hope you can read it, summarize the current status and the legislative tools currently available for approving automated vehicles. Indeed, the tools already available are the one in green, and you can see here the guidelines as I mentioned, but also the UN regulations for cybersecurity over their updates, and the already famous EUCAD regulation 157. You can also read about the indeed ongoing effort planned for 2021. So at EU level, the Commission is working on, with focus on urban applications, namely shuttles and robotaxi, and is drafting a EU text. At the same time, the Commission is also involved as co-leader in the short-term UN effort on the amendment of the LKS regulation to extend its scope for including also lane change and high speed. And basically, this is my main message. So for this year, we can expect legislative text covering shuttles and robotaxi at EU level, and also highway chauffeur at UN level. And it's also important here, and I wish to highlight this as Geoff, the need to amend national regulation concerning liability and traffic rules. And as Commission, we are encouraging the member states to do that. Next slide, please. So here is indeed my last key message, what we can expect for the future then. So after working on motorway applications and with the extension of LKS regulation and robotaxi and shuttles, the Commission will also work on other use cases like track motorway and also confined areas application, valet parking, and also on the general regulation for ADAS. We also expect UN to address other use cases than motorway, and this is currently done within the informal working groups VMAT and FRAV that are developing a top-down generic approach. And I can clarify, FRAV is dealing with functional requirements, while VMAT is dealing with validation methods. And this brings me to the end of my presentation. Next slide, please. Thank you very much for your attention, and also many thanks to all JRC colleagues who are contributing to this work I presented today.
Thank you very much, and thanks to all the speakers remaining on this presentation. Okay, you have the answer to your slide of poll, Christina. So the audience thinks that the autonomous vehicle should be at least as safe as human driver with state-of-the-art ADAS technology for 70% of the participants, for 25% at least as safe as human driver, 25%, yeah, and as safe as reasonably achievable, no need to set minimum safety level, it's only 5%.
Very
so,
interesting.
Yeah,
Thank you.
yeah, interesting indeed. Any questions to the last presentation? Michele?
Yes, sorry for delay, but
No problem. I mean, we are
just
at the end now, we are moving.
There are just one question that I put here right now.
Okay.
Just give me 1 second. The GSR mandates, I will highlight it. Can you see that one as a first? The GCR mandates a deadline for publication of technical details 15 months prior to July 2022. When can we expect the rest of the delegated acts?
Okay, so
well, that's that's a difficult question. As you see, I can tell you that we are working heavily on the technical requirements that I mentioned to be completed by the end of this year.
Okay, thank you. I would take the opportunity to link to the last presentation for an additional question. Michele, if there are other questions to Ms. Galassi, since we are at the end, then we move back to artificial intelligence, but...
Yes, there is another one for Galassi.
Yeah.
Let me just, one moment, I highlight it. What are the initiatives of GRS related to trustworthy AI, meaning based on European values and fundamental rights as suggested by AI high-level expert group?
Specifically, we are not considering AI in the approval process yet. So of course, this will come at a later stage. For the time being, we consider that the vehicle will not be capable of learning once on road. Still, this poses challenges again because of software updates. So we know that the vehicle will not anyway be the same as we approve it, and that indeed its safety performance will evolve through the time. And that's why we are also pushing for this third phase in the approval on the monitoring of in-service performance. And I guess this will be even more important once AI aspects will be introduced. Thank you.
Okay. Thank you very much, and thanks to all the presenters. To start with the panel session, I would like to talk about a subject that also was raised from the JRC through a poll about AV operation aftermarket introduction. So if we can, yes, the poll is, what do we need to know about autonomous vehicles operation after market introduction? Nothing. Relevant data about accidents, relevant data about accidents and traffic law infringement, relevant data about incidents, accidents and traffic law infringement. And fifth is relevant data about near miss, incidents, accidents and traffic law infringements. So the audience, please set your opinion. In the meantime, are there any comments, any questions? If not, I would go to another another topic, which has another question to the audience, which is the artificial intelligence topic. Let me check first if we have first results from the poll. So it seems that most of the audience has answered quite quickly on the highest amount of data, right? So relevant data about near miss incidents, accidents, and traffic law infringements. So I take this opportunity maybe to interview also not only the public, but the panelists to know what is their opinion on this while this poll is ending. So maybe starting from our Canadian colleagues, Nikki, what would you say in this poll?
I would agree. I think the relevant data about near miss incidents and accidents and traffic law infringements would be the highest.
Okay. Geoff, Knapp?
Yeah, I would agree with Nikki, and I would say that a near miss is just as important as an accident itself, so more data is better.
Okay. Professor Zielke?
Of course, more data is better, but at the same time, you will have to develop methods, kind of data mining, find out the relevant structures here for that you have to act on.
Okay, okay, thank you. And Mr. Otaigui?
So I agree with the relevant data or near miss incidents, accidents, and traffic law infringement. However, it depends to who is address this question. So it's not the same to have this information for people who are managing or are part of the infrastructure management or are some kind of public body who which the vehicle is driving on their roads, or the general public, which is in mass media, what we need somehow to show. So it depends a little bit, but from the research point of view, for sure, more data is better, and data structuring for analyzing which data and for what we are using and gathering those data.
Okay, thank you. Mr. Barr?
I cannot repeat, I will not repeat what my colleagues have said, but yes, I believe that data is important also to create different scenarios and for the knowledge. So yeah, I would say also the first one.
Okay, and to Ms. Galassi, so your question about what do we need to know, you meant, at least as I read it, the general public, right? Or is it, what's your position, or with respect to this poll? So what's the exact question? So the general public or differentiated?
I think this applies to everyone. So first of all, what the regulators need to know. Mm-hmm. But then we, thinking about this in-service monitoring exercise, we also thought about a broader audience, because indeed, when I mentioned the safety confirmation is for the regulators, but new scenarios are also relevant for all the manufacturers and probably also suppliers, and also the lessons learned, they are relevant also maybe for the general public. So if we look at other transport sectors like aviation, railway, maritime, in Europe, they are already working on a common database to share lessons learned. And this is indeed a well-established practice since decades. And not only they could achieve a higher level of safety, so a higher, safer technology and a better regulation, but these safety recommendations are publicly available on the ECARE's website. So the safety recommendations are also maybe good to know for public.
Okay, thank you very much.
Welcome.
So let's change a bit the subject and go back to the artificial intelligence system definition. So we heard about Zielke's presentation on the standardization issues of the artificial intelligence system. So ISO standardization has to define what an artificial intelligence system is and what systems are not an artificial intelligence system. And currently, common dictionary definitions do not capture the characteristics of an artificial intelligence technology. That means that a suitable technical definition is crucial for the standardization. So the Professor Zielke wants to ask to the public how they see an artificial intelligence system. So maybe if you want to add anything, Professor Zielke, about before we launch the poll, or while we are launching the poll, if you want to comment.
Do you want me to comment on these questions, on these different alternatives? Yes, yeah. I mean, basically, it's the crucial question, how do you define an artificial intelligence systems? So we know that we will get regulation for artificial intelligence, and eventually they will also apply to automatic vehicles, for example. But if you have regulations that address artificial intelligence, then you have to have a definition what an artificial intelligence system is. And there is no agreement so far in the technical community. And the two alternatives I put on the screen are basically different approaches. The one approach defines an AI system by what the system is doing, and the other approach defines an AI system by inherent properties. And so I'm interested here how the experts in the audience see this. What is more important for the definition of an AI system?
Okay, so again, the first definition is a definition based on AI system functionality. So an AI system is a machine-based system that can, for a given set of human-defined objectives, make prediction, recommendation, or decisions that influence real or virtual environments, while the second one is related to its inherent properties, right? So it's an engineered system that builds, maintains, and uses a knowledge model to conduct a predefined set of tasks for which no optimal procedure has been provided to the system itself. So in the meantime, we can check the poll is quite balanced. Maybe it's an indication that the problem of definition, and especially definition applied to standard, is quite complex. Did you expect such an answer, or?
Well, I can tell you from the responsible working groups in ISO, it's currently a very hot discussion topic, and there is a struggle between different groups and countries, and it's not easy.
Okay, so quickly, as we have to move on to let some Q&A session happen too. Quickly, almost 58%. Can you reproject the slide? Oh, yes. 58% answered for the first definition based on functionality, and 42% on the second definition based on inherent properties. Okay, let's move to another discussion involving the public. So again, JRC is asking a poll to the audience about autonomous vehicle verification. So we are changing again subject about testing, verification, type approval, etc. So this Slido poll is, do you believe that autonomous vehicles verification through physical testing at type approval is fundamental, a complementary aspect, but other approaches are needed, or no more necessary? It should be replaced by simulation. We have talked about simulation, in particular, the third presentation, I think. So let's start the poll, and in the meantime, I would like to ask panelists about the verification and about this question. So the AV verification, maybe starting from an institution that deals with the verification, which is IDIADA. So maybe Mark, you want to comment?
Okay. Well, I believe that the increasing number of scenarios against which a function should be addressed, if you multiply it by the number of present function of the vehicle, it's impossible to address the validation of the systems through a traditional method, which is purely based on test track or laboratory testing. So consequently, alternative approaches need to be considered. A method consisting on a combination of physical testing, not only in test track, but also in a real world, plus the assessment of the safety concept of the manufacturer with the support of simulation, it's a key to deal with this complexity. all of those methods need to be combined wisely and considered together in order to take advantage of the strengths of each one. So this is my approach to this slide.
So you would vote for complementary, so
yeah,
several approaches, right?
Yeah.
Yeah, okay. And I would like to ask Oyana also comment on this question.
Yes, I agree with what Marta has already mentioned. That is a complementary, that the complexity of the functions that need to be assessed is increasing. This requires a large number of testing scenarios, possibilities that running only using traditional methods is unforeseeable. So we need somehow to combine different ways of testing and validation, and the simulation is one of those. We need somehow in the future, in the coming years, thought about the integration and balancing between what we need to simulate, what we need to do in real testing and physical testing. The representativeness of each of the testing and how can we fix or see what means one driven kilometer versus one real world driven kilometer, and how to have complete traceability of what we are testing in each of the methods that we are using. This is going to play a key role on the whole testing and validation process.
Okay, thank you very much. We need to move on for the last topic, but are there comments from the other panelists? So.
Yes, Filippo, I would be interested in knowing whether technical services are ready to run also simulations beside the physical test. Oh.
Okay,
that's
so
an additional question, sorry.
To Marta. We cannot hear you.
Sorry, now I'm unmuted. I would use IDIADA's example to answer about this. From the regulatory side, at IDIADA, what we are doing is we are increasing the amount of experts attending to the regulatory forums in order to be prepared for this. We are also building ADAS and CAP test tracks in order to adapt for these new requirements and for the new regulations to come. We have also built the simulator, very big simulator, in order to do this simulation side. So this is at least how IDIADA is getting ready for what is to come. I believe that other technical services, for sure, they will be also getting ready. And yes, I can answer at least from the other side that this is the way that we are approaching to the new changes.
Thank you very much. Very interesting.
Thank you very much. So let's move on to the last topic before we go to the free Q&A and try to address the many that have come. If I can have from the organizers project the good slide from the first presentation by CSA, slide number 7, about the identified gaps and critical need for AV deployment and standardization. This is actually the main objective I want to recall of this session. So here you see them projected: harmonization and interoperability, uncertainty with communication technologies. We have had a question to the public about the functional safety, for instance. It's one of the issues. There is, for instance, also safety of the intended functionality as another kind of standard to assess communication technologies. Compliance verification, physical infrastructure is very important as well. The ODD is something that is ramping up now that we have level 4 automation in sight coming. High definition mapping and localization, cybersecurity and protection of privacy, of course, and as a whole, technology maturity. So I would like to ask to our panelists to prioritize, pick just one of the items, what is for you the main problem pending that should be solved for the deployment and the acceleration of a safe deployment of connected and automated driving? Thank you. Okay, starting, excluding for a moment our Canadian colleagues that did the research. So I would start with Zielke.
Yes, my top priority would be the maturity of the technology. Yeah.
In general, okay, the maturity of technology. Oyana, yeah, you're the next.
Yes, I will agree with that one, with the maturity of the technology.
Okay, Marta.
I cannot see the slide, but I agree with my colleagues. But I would like to say something on this, which is that we need to align and unify open road testing requirements in the different member states, because we need to consider that without testing, it's not gonna be possible, the deployment. So this is just a comment or a reflection that I wanted to share with all of you.
Okay, does it also need relate to the requirements of the road infrastructure? So in the slide 7, there was a requirement on the road suitable for autonomous driving.
Yeah, I would say that it's related, but I was thinking more on, for example, talking or referring to Ensemble, which is the platooning project. We have seen that depending on the country, they are requesting different things, very related, but different ones. So my issue or my point in here is, I know that CCAM Working Group 4 is already working on this, but we should keep working in order to have a mutual recognition or a common framework just for testing, and then we can go to the deployment.
Okay, this seems like more a non-technical barrier, right? So that's about agreements. Okay.
Yeah.
Okay. Maybe about agreements. I would like to hear the opinion from JRC, and yeah, if you want to comment, is it also for you a high priority issue, this, Cristina?
Well, as first, standardization gap that would come to my mind to allow faster deployment of the technology would be, indeed, even before the technology maturity, would be the maturity of the safety management by the manufacturer. So I think standardization is needed mostly there, because technology is quite ready. And indeed, it's very important to be able to test the technology also on road, as mentioned by the colleagues. So the work done by Working Group number 4 in the CCAM platform is indeed going in that direction. But I would say that the first gap, the first and most important gap for me would be on standardization concerning, for example, the safety management system and the terminology and the safety objectives. So how safety is managed.
So related also to ISO 26262, functional safety, you mean, or more in general?
A higher level, actually.
Higher level, okay.
Yes, that would be, about functional safety. So how to ensure that in case of failures, so of software or mechanical components, everything goes smoothly, so the vehicle is still safe. But what is missing, and is indeed the topic of the audit and assessment phase, the first phase in approval, is a standardized approach by the manufacturer. So how to establish, for example, the safety management system with the good processes to handle and monitor safety and to deal with changes when needed, and so on and so forth. And also safety objectives, how to set safety objectives.
Okay. Okay, thank you very much. If you don't mind, now I would give again the floor to Q&A session. So Michele, if you want to read out some questions. We have 4 minutes before ending this session.
Yeah, I would like to ask, there are many questions, you know. We can ask questions, there are some questions related, for example, infrastructure, this one.
Okay.
How is the plan for infrastructure to support the AD development roadmap? So we are talking more a lot probably the in-vehicle technology, but what about maybe standardization, roadworthiness related to infrastructure? How we are there? I try to interpret it, the question there.
So
any question related to infrastructure in general?
Yeah, is anyone willing to take on this this question? Maybe I would ask, since they showed the good research in Canada, maybe I would ask the Canadian colleague, Mr. Knapp, or Nikki Kidd.
So for physical infrastructure, that was something we noted as a critical need and maybe a gap in standards. How does it support? How is it the plan for ISAD or infrastructure to support AD? We heard conflicting things on that. When you hear a lot that physical infrastructure, like line markings and consistency beyond, through borders and through different areas, was definitely a need. But we're seeing manufacturers and OEMs develop and test and put things into vehicles that are available to drivers now that don't really rely on them as much as what we hear. So I kind of go back to one of the questions in the poll where the question was, what type of data do you need? And the answer really was everything. And when you ask manufacturers what they need from physical infrastructure, we found the same thing. They want everything, but they're going to move forward with or without that. The question is open-ended. If you say what you want, they're going to say everything, and then they'll work with what they need. I don't know if that answers the question, but.
Okay, thank you very much. I would ask another question, Michele, and this will be the last one because we have only 2 minutes. We have to be sharp.
Yeah, I would like to ask this one to Professor Zielke. That, I mean, the topic of artificial intelligence, it's also always interesting. So, can we allow artificial intelligence to decide without traceability of the reasoning, while legal case demonstrability will request to trace root causes analysis in case of accident?
Yeah, of course, that's a really crucial question. And I was mentioning some symbolic AI and symbolic AI in the past. Symbolic AI played a big role in artificial intelligence, mainly because it was explainable. So it was clear to everybody what is going on. So everything could be validated and verified, which is not possible anymore with, for example, deep neural networks. So I think the trend here, the technology trend here, is to develop very powerful AI modules by, for example, neural network technology, which you cannot understand what is really going on in there, but you can then develop technology that is trying to extract knowledge from these models that have been trained on data. And so if you extract knowledge, then you can kind of make a bridge to the symbolic AI field. And there you can then look into what's going on, and there you can find explanations.
So thank you very much. Unfortunately, the time is over. It's a pity because the conversation was really interesting. We have seen different aspects of standardization of connected and autonomous vehicles. I thank very much the organizers and the European Commission supporting this EUCAD conference, and also for the public proactive interventions in the poll and question. Thank you very much, and have a nice day. Thank you.
Thank you.
Bye.
Thank you.
Thank you.